So hopefully you're here for the future of data on Kubernetes, from database management to AI foundations. We're going to really dive into some of the use cases for data on Kubernetes around AI and what's going on, what we're seeing from customers. I'm Rob Strechay. I'm a managing director and principal analyst and member of the DoK community. I'm here to moderate this panel and really help guide this through and get you guys some information. Hopefully, we'll have some fun with this and have a little time for even some questions at the end. If you need anything while you're doing that, the exits are back there. You know where to go. All that stuff is taken care of. So before I go into kind of a little bit of an overview, let the panel introduce themselves.
Hey, I'm Nimisha. So I'm a software engineer at Confluent, where we mostly work with streaming services, so Kafka, Flink, things like that. And we offer a data streaming platform, a managed version. And we have an on-prem and cloud offering and everything. So personally, I'm mostly involved on the Kubernetes side because I'm on the platform team. So it's like internally managing all of the data infrastructure, all of the Kubernetes stuff, providing self-service to our developers to build the actual applications and maintaining system software on these clusters and so on. Yeah.
Thanks, Nimisha. I'm Gabriele Bartolini. I'm Vice President and Chief Architect of Kubernetes at EDB. EDB, for those of you who don't know it, is the #1 contributor of the Postgres open source project, and also the creators of CloudNet EPG, which is a project that just joined the CNCF sandbox. We help organizations all over the world run Postgres also for AI purposes. I'm from a community side, I'm a PostgreSQL contributor. I'm a Data on Kubernetes ambassador. So my objective here is to tell everyone that it's not only okay to run databases in Kubernetes, but it's, in my opinion, the best way to run them.
You're not alone. My name is Brian Kaufman. I'm a product manager working specifically on GKE and the GKE data layer. So if you're running stateful applications such as databases on GKE or AI/ML workloads, particularly inference workloads, I'm the product manager you might have worked with. Prior to Google, about 7 years ago, I worked at Docker, so I might have tried to sell you all Docker Swarm. This, ironically, is my first KubeCon, so super excited to be here and just can't get over the excitement and all the new companies that have popped up since.
How many of you is this your first KubeCon? If you just put your hand up. Nice. That's great to see. It's always good to see about, I'd say 60% of the community here is new. First KubeCon, welcome. I'll screw that up a couple more times before we're done here. One of the things that I'd be remiss if I didn't kind of talk about a little bit is the DoK community. Obviously, there's a Slack channel where it's very active. There's a lot of things you can go in there and get involved with, data on Kubernetes. There's also the latest report that talks about what are the kind of deployments that are happening, what are people doing with data on Kubernetes. That report really had some interesting things, because if you think about AI and what feeds AI is really data. And you want to keep, especially if you're going in your companies, your organizations are investing in GPUs, be it in the cloud or on premises or in colo, those are expensive assets that you want to keep busy. So having GPUs be busy, you need to really have the right data architecture, and have that on Kubernetes makes a lot of sense to keep them busy as well. There's a lot of AI and ML acceleration that is really being focused on. In fact, I had some stats that I wrote down here. If you look at the maturing ecosystem, about 50% or more of DoK workloads are in production. So this means, to Gabriele's point, it's okay to go and do stateful related applications in Kubernetes, and how you do that, you'll get to hear a little bit more about how that happens with things like databases and streaming and others. So again, we'll also get into some of that, because really 75% of those production environments really have advanced within those organizations and are really joining in a lot of that data on Kubernetes. Specifically, one of the biggest use cases is around AI and how quickly you can get up, you can iterate and move through things. There are challenges that do remain. I would say that, really some of the features still in Kubernetes is kind of one of the #1 barriers, and kind of the skill sets around that and being able to bring that up. And there's a lot of different discussions. There was all things on platform engineering yesterday and platform engineering day. But there's a lot where even AI will help with that stuff as well going into the future. So really good stuff. And I think, what I really want to start off with is, and we'll kind of go around the horn here, are there any customer stories that really stick out to you that you've thought about in the past, year or past 6 months since Salt Lake City, that really, when you start to look at data on Kubernetes and how it's supporting AI or ML, and it doesn't have to be just generative AI because there's still traditional AI out there, still a ton of that. Anything you can think of, a customer story that, hey, this is how they got started and where they went.
Yeah, I can start off. So one of the interesting trends we're seeing with AI/ML workloads, and I'll relate it to all the great database work you're doing, is the use of local SSDs for caching. So a lot of AI/ML workloads, particularly RAG, you need to do a fast read of a vector database before you ingest that, take it as context to send it to a LLM. Traditional databases, they're meant for low latency, but when you're talking about AI and the amount of hops you need to actually get the answer you need, the latency is just infinite. It's just way more important now. So caching is a huge thing we're seeing in the industry relatively recently, with the use of either RAM disks or local SSDs to get the data that much closer to the GPUs for the processing. So that's a trend we're seeing across the customer base.
Yeah, thanks, Brian. So I can certainly name one. For example, as EDB, we have a customer, the US Navy, that they use Postgres on Kubernetes, and also for ADB Postgres AI. But I can talk about also the project Cloud Native PG, because the list of adopters is public, so you can actually go through that and see what's happening. It's growing, but what's interesting for me that I've started this journey 5.5 years ago when my first KubeCon was San Diego. I was there with Marco, who's here from my team. People thought we were crazy. We wanted to use local storage, and people, they laughed at us all the time. It's changed, but the perception from, at the technical level is improved. We need also to elevate that to the business decision makers, because there's still a lot of work to do. But what is interesting is this change of mindset that you can. I wrote a blog post about cloud neutrality, and I'll talk about that later. It's about this reuse of bare metal machines and local storage, which requires a bit of adaptation, a bit of understanding that is a change that the organization has to do to provision, for example, hardware and so on. But another use case I want to cite is IBM Cloud Pak, that is using Cloud Native PG for all their database as a service solutions, for most of their database as a service solution, which then provision data for AI. And for Postgres, it's important because there's an extension called PG Vector that transforms Postgres in a vector database.
So I don't personally work too much on the customer-facing side, but an interesting pattern I'm seeing is a lot of companies are moving their intelligence into their data processing pipeline. So into the pre-processing and post-processing specifically. So especially when it comes to streaming, one cool thing you can do, especially with like Apache Flink, for example, is hook up an LLM right into the processing pipeline. So even before your data gets to your destination, you can already make intelligent decisions based on that data. So it can you can do remote inference from a pre-trained model, for example. So yeah, that's something I'm seeing.
Yeah, and I think if you look at any of the larger databases of services and things of that nature, they're even those ones that are hosted or PaaS related are even moving towards either serverless or Kubernetes-based infrastructure underneath the hood. There's been some announcements out there around some of the larger ones. One of the ones that is going completely serverless, for instance, is Databricks has said their entire cloud-based service is going serverless at this point. But they're all, I think, to that point. But Gabriele, like what is it and what considerations should people look at? Because database is really the #1 category of data on Kubernetes. What are some of the things that people should look for or try to avoid, or things that could get them on that golden path to success with databases on Kubernetes?
So the latest report says that, and AI is again fueling even more the adoption. I think a key aspect here, and that's for Kubernetes in general, is the fact that we can use declarative configuration for everything. This is a declarative world, and the complexity here is for operators to guarantee that. And when it comes to a database, that's really key, especially if you want to launch analysis on data and even recreate data just for the purpose of some analysis process. So the importance here is to simplify the operational complexity that is intrinsic in a database through what Kubernetes globally allows you to do. So this is, I think, the reason why databases are excelling is because there are operators that enable that and enable to run a database in this amazing infrastructure orchestrator that is Kubernetes. So in my opinion, this is also the challenge for us. But the challenge in general that I see when people try to use databases in Kubernetes is if they come from Postgres, for example, they don't know Kubernetes. And that's the challenge #1. And if they come from Kubernetes, most likely they don't know Postgres, and they don't know how Postgres needs, for example, to access and to own the storage. There's this very close relationship between Postgres and storage, and it's where I think a lot of innovation will come. We have, for example, one of our maintainers of CloudNet EPG is also working actively in the Kubernetes storage for this reason, because it's probably an unexplored world, but just to remove your concerns, it's already better than what we have in VMs, according to me. So it's all new world for the better.
Yeah, and I think that is one of the things when you look at the CSI drivers and the maturity of things. I was at a vendor at one point in time, and this is almost 10 years ago now, and we actually built CSI drivers back then. So when you start to look at it, it was just when Kubernetes was coming out to give it access direct to the storage, which becomes a really important part. But let me throw it over to Brian now. And Brian, there's a lot of considerations, and you sit in a unique spot being at Google, that AI/ML really has some operations that you have to consider when you're doing data on Kubernetes. What are some of those considerations, and how do you see, or what have you learned that you can impart on them that they can kind of get their Kubernetes ready for things like AI/ML?
Yeah, so it's a very loaded term, right? AI/ML. What is that? How many folks in the room do training on Kubernetes for AI? Okay. What about
10 hands?
Yeah. What about inference? Okay, a lot more inference.
That was more.
So I'll split the question up. So for training, what's most important, and you all can keep me honest, is let's take a step back. For training, you spin up your nodes ahead of time in Kubernetes, and then you're downloading all the training data, and then you're pushing back up all the checkpoints. what we've seen with the training data specifically, it's usually a lot of small files. So a trend we're seeing across our customer base is a lot of caching and parallel downloads for those small files to be able to make sure that they're there for more than one epoch, right? If you're going to be constantly reviewing those files, you don't want to keep downloading them, usually from object storage. So for training, the trend we're seeing is the parallelizing of all the downloads and the caching of those small files so they're available for subsequent training runs. On the inference side, how many folks, so the folks that are doing inference, what inference engine are you using? Are you using, raise your hand if it's VLLM, okay, or Triton, okay, there's, a few more, all right. Training, very different from inference. Inference, you're going to be scaling up and down like a normal web service, right? Training, everything's set up ahead of time. Inference, you're scaling up and down with the workloads. And what's most important when you're scaling is making sure that the hardware is available when you need it, but not a second more. And with inference, instead of a lot of small files like you'd have with training, you have very, very large models and weights potentially that you need to download from object storage. Llama 70B, it's like 130 gigs, right? So if you've tried to download that from Hugging Face, I won't do any more pop quizzes, but it's about 20 minutes to download that model from Hugging Face. So if you're linking Hugging Face to your Kubernetes cluster to run inference, it's 20 minutes of idle GPUs you're sitting on there. So with inference, what we're seeing is similar storage acceleration from object storage, so parallel downloads. We also are experimenting a lot with a new feature in VLLM, the Run AI model streamer, which allows you to do a similar parallel download to some of the Google products like GCS Fuse, but go directly to CPU memory and then to GPU memory. So the model streamer is a really great accelerator built right in VLLM for that. We are also seeing people storing models on block storage. And the advantage to block storage over object storage is you can make it immutable. So you can just set the disk to read only and then ingest it, usually from a location within the same zone. So really different strategies for both inference and training, whereas inference, you need ultra low latency. Training, it's not as important. And that goes back to just some of the things I was discussing before, where training, like it's a big deal if a node fails, right? You need to restart from the latest checkpoint. Whereas inference, if a node fails, it's kind of a big deal, but not really, because it's in an auto-scaling group and a new node will pop right up, right? But again, you got to download the file, and hopefully you're not just pulling it from Hugging Face. You have some storage acceleration built in there. So different strategies depending on how you're loading, or I guess what part of AI/ML you're working on.
No, I think that's so accurate. I was just talking with one of the other maintainers of VLLM, and I think that when you start to look at the size, and we talk about on theCUBE a lot, and do a lot of research on it, that the size in small language models or segmented language models and things for inference, where you have a long tail, where you'll be doing way more of that than you will be of training. Maybe you're not going to be constantly training models per se. You may be taking them in, you may be fine-tuning them and building them to be and meet your specific needs. And that does take up a lot, it takes up a lot of data, but then when you push them out somewhere, they're a much more subsetted amount of data that you're bringing out to that edge potentially, where you're actually serving out that model and things. But Nimisha, let's kind of switch gears a little bit and look at streaming and data management and what the impact has been on the DoK ecosystem around that from your perspective, because that's another set of data that I'm near and dear to my heart. Helped build a SaaS platform that used that type of streaming data to bring and do AI/ML on top of that as well.
Yeah, for sure. I'll start by saying, like, data is most useful when it's fresh, right? When it's the most recent, because it has a lot of value. And especially for AI, you want the most recent data because you want the most recent up-to-date context for your queries or any kind of useful information you want to extract from your workloads and pipelines eventually. So obviously, this is nothing new, but for anything involving real-time data, people use hybrid systems. So no longer, I mean like no longer batch processing, but they're doing real-time processing, event-driven processing, especially when it comes to inventory, like anything you want to do where you want to manage inventory, supply chain optimization, anomaly detection, things like that. But on the AI side, more specifically, I mentioned earlier about moving intelligence into your data processing pipeline. So one cool architectural pattern I saw recently was basically a lot of people are using agents these days, right? So an agent is just something that can take an action based on some data. So let's say you have an agent that's interested in looking at so many data sources and can take a certain action based on that, like maybe let's say to send a notification to an operator, or maybe it can auto-approve some kind of thing, workflow. And a lot of people are using multi-agent systems these days. So they have all these agents working together, but they use streaming data to act as the brain to orchestrate which agent should do what, because you do need something in the middle that orchestrates these agents. So the way it would work is like you would have Kafka as like the streaming backbone for your pipeline, and like it is doing all the delivering of data. So from the sources to the sinks and downstream services. And on the way, if you also add Flink to it, and like I said earlier, if you hook it up to an LLM, you can take in that data in real time, make a decision about which agent to invoke based on what kind of data is coming in, and then invoke that agent. So yeah, that's an interesting architectural pattern.
So let's stay here with you, and this is to everybody. Let's what do you think the evolution of AI, ML, data on Kubernetes, and Kubernetes in general is going to be over, say, the next, we're at the 10th anniversary for the CNCF almost, so in the next 10 years of the CNCF, how do you think that's going to evolve? And from your own perspectives, obviously.
Yeah, finally, we were just talking before the panel that a lot of these CNCF projects work sort of in isolation, but trust the other pieces to work too. And ultimately, all of it has to play well together too. So that's going to continue to happen, I believe. So I think it's going to be like, why do people want to come to Kubernetes, right? It's mainly for a lot of stuff you get out of the box. So you get auto-scaling, fault tolerance, security, a lot of investment into all of these areas. And I think it's also the ecosystem, because I think there's going to be a feedback loop between end users and these projects, the open source projects in CNCF. And there's always going to be, it's like a growing community. So as that feedback loop is completed, you'll have new features being added to the ecosystem, and all of it co-evolving. The development will influence the application and vice versa. So that's something I definitely see happening. Yeah.
Yeah, I mean, yeah, exactly. We were having that conversation, very interesting. And I believe there are essentially two things, in my opinion. One is the integration among projects. So, for example, I bring my case of CloudNet APG, where we are interested to get, for example, every project that uses Postgres as a backend or as a client to maybe work together to improve documentation, to help end users use these products together. This is, I think, something that through the CNCF we can elevate. The other thing, from the Postgres perspective, I've seen already in the last couple of years how just by running Postgres in Kubernetes, we've produced ideas that in 30 years before Postgres had never produced. Even small patches, but they are going to change the way we can improve things in Kubernetes. For example, one patch we will introduce in Postgres 18 will help how we can deploy extensions in Kubernetes, thanks to another improvement in Kubernetes, which is event volumes. So by doing that, for example, if you want to load an extension that does some AI analysis and processing, you can do it and then remove it. So I think these are the two things I can think of.
So I guess what's top of mind for me is, specifically with regard to AI ML, the configuration responsibilities to really make an efficient workload possible are now outside the boundaries of the Kubernetes fabric. So for instance, I spoke before about object storage. Guess what? There's tuning you could do on object storage, right? There's tuning you can do on block storage, on the networking layer. A lot of things that are perhaps under the Kubernetes fabric that most folks have access to. I spoke a lot about caching, right? Setting up caches, all the sorts of things to accelerate the downloads. Potentially, those are using APIs that are outside of just the Kubernetes control plane. So what I see happening, not only with regard to AI/ML, but with just the broader Kubernetes ecosystem, is taking advantage of the Kubernetes control plane to bundle infrastructure and applications as a logical entity. So some folks in the room might be familiar with projects like Crossplane or KRO. They're ways that you can group different artifacts in Kubernetes, be it deployments or perhaps load balancers, network configurations, secrets, everything that is outside of the cluster, but perhaps in the hyperscaler or data center you're using, or external APIs. So I think that with all the nuances to AI/ML, it's getting more necessary to package the infrastructure configuration with the application configuration.
All right, so kind of last question here is everybody's favorite question is around cost. And how do you deal with and control costs in data on Kubernetes? Because like you were saying, there's so many different places. Data is, like I said, feeds AI/ML, and it grows exponentially. So,
yeah,
to all of you.
Tell me, I'm the PM for storage, right? I know about that. Yeah, not the dirty word, but it's latency, right? In my world, that's what the other word for cost, right? Is latency in GPUs. That's right now the most expensive part of the stack. Controlling costs is really centered around making sure you have proper observability to make sure that you're maximizing every route into the GPU that you can. I spoke a lot about caching. That's like a layup. Make sure the data is as close to the GPU as possible. Control your costs. Most of the people in the room probably already know this. Local SSDs, much cheaper than memory. So if you can push the latency to the local SSD and it doesn't affect your application performance that much, guess what? You might not need to size up the VM that you're using, and you could cut down on that expensive memory, which I could speak to Google is about maybe $3 a gigabyte a month versus a local SSD, which is about 8 cents a gigabyte a month. So, very big, very, different price point there. GPU idle time, you want to avoid at all costs, which I think is fairly obvious.
Yeah, and then I'll cover primarily the database stuff again. So what we see it's happening is this. We recommend to isolate Postgres worker nodes from the rest. So that gives you, for example, if you can use bare metal machines with local storage, that gives you a fixed cost. Okay, so you've got a cost predictability on the database layer, and you can use Kubernetes to consolidate your databases over there. This means that in terms of procurement, I speak with customers that tell me, it's too late now to add more nodes, okay? But you can do it for the next year, and for this year, maybe still, work with the way you are used to work. But this is why it's important to start even from day zero to plan for your infrastructure in Kubernetes for data workloads, because it can help you save a lot of money.
So I agree with Brian about the observability part. I think that's like the number one thing. Obviously, like internally at Confluent, we implement robust like resource tagging policies. So every cloud resource, we know which team provisioned it for what, when, all of that stuff. So that's important, and do all of the auditing for all of this too. But in terms of strategies, I think one thing that pretty well known at this point is obviously in the cloud is cross availability zone transfers for data. So you want to minimize that, and I think there are ways to do it, like obviously co-location and using let's say, what was it? Affinities, yeah, affinities and labels and things like that to co-locate your pods with your data processing, all of that in the same AZ. Yeah, I guess that's mainly it. Oh, there's, I think.
Go ahead.
Yeah, no, sorry, I forgot my point.
Yeah, I mean, just to say, when I meant isolate worker nodes, it was to use stains, tolerations, and entire affinity. I implied all of that. And as I said, that cloud neutral Postgres, you can find an article about that.
Awesome. Well, thank you, everybody. We ran out of time. Sorry that we didn't have time for questions, but thank you for here. If there's a survey, fill it out, and we hope to see you again. Thank you.